Hello and welcome to the AQA GCSE 8300 3H. This is the third paper in the higher tier, and this is a calculator paper, and we're picking up in question 23. A container is filled with water in 5 seconds. The graph shows the depth of water d centimetres in time t seconds. So here's our depth and here's our time. And as we can see, it fills up quickly at first and then slowly starts to fill up a little bit less quickly. In question 23a, it says the water flows into the containers at a constant rate, or the container at a constant rate. Which diagram represents the container? Circle the correct answer. Okay, well, if it was A, we would see the depth would just increase at a constant rate. So we would expect to see a straight line from 0 to full. In B, it would fill up slowly at first, and then the depth would get faster and faster and faster as the width sort of narrows. So we would expect the curve to be slowly and then increasing in speed, finishing up here. So it would be almost the mirror image of this one. So as we expect, C, which is almost the opposite of B, this would be the correct answer. The graph, the depth fills up quickly at first and then slower and slower as the width increases. If it was D, we would expect the graph to fill up fairly quickly, then slow out during the middle and then quickly again at the end. So our answer here for question 23a is C. That's the one you want to circle. Now for 23 part B, it says use the graph to estimate the rate at which the depth of water is increasing at 3 seconds. You must show your working. It doesn't say you have to show your working here. Well, you will need to show your working here, but you also need to show your working on a graph. Now I've taken the trouble here to draw a tangent line at t equals 3 seconds, because this is how you work out the gradient of the graph at 3 seconds, because we want to know the rate at which the water is filling up at 3 seconds, and the rate is the gradient of the graph at that point. Now we don't want the average rate over a period of time, we want the actual rate at 3 seconds. So that's why we've made a tangent line, and a tangent line just kisses the curve at one point only. So you're going to want to get your clear ruler that you can see through, and you're going to want to adjust it so that it just touches the curve at one point only, and that one point only must be at the 3 second mark. And from here on in we can just measure the gradient of this curve, and that's measured by the rise, which is how high it goes, divided by the run, which is how far across it goes. So it goes across from 2 to 4, so the run is 2, and the rise, it goes the way where I've chosen to stop, it goes from halfway between 15 and 20, which is 17.5, up to 25. So our calculations is 25 minus 17.5. Oops. Sorry, that's 17.5, not 1.75, it's 17.5 divided by 2, which, if we get a calculator, 25 minus 17.5, which is 7.5 divided by 2, it's 3.75. I make the gradient 3.75. And these are the calculations that you want to put down here in your answer. Hope that was helpful, and I will see you in the next video.